All right. So we are talking about reflections. We are beginning chapter 3. And reflections means a mirror image of something. So I look in the mirror and I see my face. My hands are a reflection of each other because they're the same thing. Right? So the vocabulary, a transformation is an alteration of any image on a plane. A rigid motion is a transformation, so it preserves the length and the angle measure. So this is going to be the same size. Okay. A reflection is a rigid motion, so it's a movement that reflects each point in the pre-image. So we're talking what pre-image? The pre-image is the first image across the line of reflection. So I'm going to give you like a line and I'm going to say reflect this, reflect my hand over this line, and it would be like, I can't do it. Reflect my hand, and it'd be like this. Oh man, that was a bad example. Sorry, my arm doesn't go that way. You reflect, the image goes across a line. The pre-image is the before, so that'd be like, I'd call it like image A, and then the image I would call A prime. So the little apostrophe means the word prime. The little apostrophe means the word prime. So I got my pre-image, the first image, and then my image is like the next image, but I say prime. So example 1, is each transformation a rigid motion? That means it stays the same size. So this I would call like A, and this I could call like A prime. But is this the same size? No, not rigid motion. Okay. This one though, this would be like B and then B prime, I'd say. And then what that means is, like, even if I turned it, is it the same size? Maybe it's just turned a different way. And yeah, see how this short end, long diagonal, yes. This is a rigid motion. Okay, so yes, it is. Yes. Okay, reflections. Reflections mean that something is flipped over a line. So I've got point A is on line M. So see this dotted line M? Point A is on it. But if I were to reflect it when it's already on the line, it's still going to stay. So that would be A prime. There's a little apostrophe there. A prime with a little apostrophe. Now point B is not on the line. So what happens is this point B flips over line M, and this becomes B prime. I just wrote it a little bit bigger, okay? B prime. All right. So this line M is the line that I'm reflecting over. So this is like a reflection. And then the M goes down here saying what I'm reflecting over. I'm reflecting over line M. I could also reflect point C. Look at point C. When I reflect it over, it's the same distance from the line, but I'm going to call it C prime. C prime. Okay. So this is just the general basics. All right, now I'm going to start using my tracing paper. Use the properties of reflections to draw the image of the following figures. Okay, triangle FGH. So when I use tracing paper is see-through. Remember, we also call it parchment paper. So I need to be careful because I'm going to line it up. I'm not going to just randomly have it in the middle of the paper. I want to make sure that I have some sort of boundaries. Like I'm going to put the edge of the paper along my line of reflection. I also think that it would be a good idea if like the corner of my line of reflection hit the corner of the paper so that I don't accidentally like shift my paper up or down and then I'm throw myself off. So I'm going to trace my image, G, F, H. Now, if I'm going to reflect this across line L, here's line L, it's going to look like this. So watch how this happens. Reflect it over like that. Now I'm going to use my tracing paper and I'm going to draw really heavy. So that way, it'll kind of imprint on my paper. This was H, this was G, and this was F. Now, when I lift up my tracing paper, you're going to be able to see the triangle on my white paper. It's very faint, but at least I still know how the triangle's shape looks. Okay, so there's the image. And if I show you this line of reflection, look, pre-image, image. This is H prime, G prime, F prime. Doesn't it look like it just flipped over? So you can see how the line of reflection truly is the triangle reflected. Okay, MNL. Let's do like here. MLN. Now, my tracing paper is lined up with my dotted line. This is my line of reflection, line N. So I'm going to go now and reflect it over. Draw heavy. M, L, N, right? So when I lift up my paper, you can see the faint drawing of my triangle. M, L, N. M prime, L prime, N prime. And look, when I hold it up, that looks the same. It's reflected over line N. And I would say reflection over line N. This is a reflection over L. So this subscript tells you what it's reflecting over. This subscript tells you line N. Here's a little shortcut. Because maybe I don't feel like graphing every single one. Maybe I don't want to. So this tells me that my x-axis, and I got to draw this for you. The x-axis is across this one right here. The horizontal line, the x-axis, right? Reflecting over the y-axis, I'll draw it over here. It's the vertical line up and down on the coordinate plane. I would reflect over that line. This y equals x is going to be, if you're given a coordinate plane with your x and your y axis, it's like this. Y equals x. Y equals 1x plus 0. Y equals x. Y equals 1x plus 0. That's the y equals mx plus b form. It's a diagonal line that looks like that. I'm going to reflect an image over that pink line right there. The last one says a reflection over y equals negative x, which is, by the way, x, y. Y equals negative x plus 0, or like negative 1x plus 0. Goes like this. Okay. So x-axis, y-axis, y equals x, y equals negative x. Okay. So here it is. Quadrilateral FGHJ has coordinates of FGHJ. Graph and label reflecting over the x-axis. That's this right here. The ordered pair starts out as whatever the numbers are, and my new ordered pair, the x value stays the same, the y value changes signs. So if I'm going to reflect over my x-axis for every single one of these ordered pairs, my x value is going to stay the same, my y value is going to have a negative switch, opposite sign. So this is now going to be my new, I'll try and write as small as I can, but you guys know I'm not very good at writing small. That's not a skill I have. Some math teachers are like amazing at it. And I am not one of them. It's 0, -3, G prime, 2, -4. Remember that only the y values change. Look at how good I'm doing. Yay. Only the y value changes sign. H prime. Ooh, if you don't have a sharp pencil, forget it. Forget it, forget it. All right. 4, -2. J prime. 2, -0. Just kidding. Don't do that. Don't be that kid. Don't be that kid that says -0. All right. Am I the only one laughing at my jokes? Okay. That's all right. I don't mind being weird. Like, okay, here we go. I want to draw it now because it says I have to graph it. I've already, let's do 2 colors, 2 colors. Pink and blue. Pink, original. OG. This is gonna be my image. Remember how it's called image and pre-image? Let's get our vocab words in use. Pink is my original pre-image. I'm gonna graph my ordered pairs of my pink. 0, 3, F. 2, 4, G. H, 4, 2. J, -2, 0. Way over here. Okay. I should be using a straight edge to make everything look perfect. Now remember, if I'm reflecting over my x-axis, that means that my shape, I'm just going to pretend that this is it, that my shape is going to go like this, down, right? Over my x-axis, the shape starts here and reflecting over the x-axis becomes below it under the x-axis. Okay, blue, image. 0, -3. F prime. I don't even know if you can see that with the blue. G, 2, -4. G prime. H, 4, -2. H prime. And then J is -2, 0. Ooh, the same spot. J prime. Okay, here we go. Okay. All right. So my new reflected rectangle, kind of like a trapezoid, right? Not a rectangle at all, it's a trapezoid, is that blue, okay? Do you see how it's really important that you as a class have tracing paper if you can? Like literally, is there some old lady that lives next to you that loves to cook because she has parchment paper? Anybody who bakes uses parchment paper. So I'm hoping you don't have to buy any, you can just borrow, because I'm only using a square this size. So if you get like, I don't know, a sheet that's like this long, you can cut it and use it for many days. And look at me. I'm like, I got one over here, one over here. I'm gonna use one piece of paper for the whole lesson. Because, you know, reduce, reuse, recycle. All right, I'm gonna turn the page. Over here. You know what I want to do for you on the top of the paper, because we're going to reflect over the x-axis and the y-axis for two of these problems here. I want to write your little cheat sheet. Reflection over the x-axis is my normal ordered pair xy becomes x negative y. The y value changes. When I reflect over the y-axis, my ordered pair becomes negative x. The x value changes sign, but the y stays the same. Okay? So, here we go. I knew, remember, x, but I have negative y. A prime is going to be -5, -6. B prime is going to be 1, 2, x negative y. C prime is going to be x negative y, -3, +4. Okay, so here we go. Original pink, new blue. I'm gonna first draw it, and then I'm gonna show you with tracing paper how it looks good. Okay, pink, original, -5, 6. A. B, 1, -2. C, -3, -4. And I think that a straight edge is best because I want it to look nice.
I have a quick question.
Yeah.
I don't know if I'm understanding this right, but it says reflect across the x-axis, but why is it only changing the y?
Because when I move from up to down, aren't I going like positive y values to negative y values? Or
Yeah.
negative y values to positive y values? So that's why only the y changes.
Okay, thank you.
Such a good question. Okay, there's pink, original. Blue, -5, -6. A prime. Point B, 1, 2 over 1 up 2. B prime. My blue pen is kind of a horrible idea. It's the problem is that these lines are so dark that it's really hard to see anything. I mean, thank goodness I'm not doing it in pencil because that'd be even worse. C prime, -3, 4. Okay. Ready? Connect the dots, la, 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 la. So, ugh, I do not like how dark those lines are. Okay. If I have this triangle here, basically, how can I do this? I'll do it like this. Okay, watch. Okay. I'm lining things up. Look at the corner of my tracing paper is lined up against the edges of the graph. My x-axis that I'm reflecting across is this horizontal line right here. So here's my tracing paper. Pink is my original, right? You got to make sure that you align things. Because if I randomly put it in the middle like this, maybe tilted sideways or whatever, how am I going to know when I reflect it? Like, well, which way do I? Be good and organized about this. And this is drawing. This is fun. A, C, B. Now watch this. My line is this pencil line that I just made. So here's my reflection. Ready? And it lines up with blue. So original, pre-image. Let's get all those vocab words into play. Pre-image, image, ABC prime. Okay. Since I already covered it, just so you know, reflecting over the y-axis means that my x value changes, not my y. Because reflecting over my y-axis means I'm going from negative x to positive x, or positive x to negative x. So I'm flipping from one side, like this is x equals 1, x equals 2, x equals 3, x equals 4, x equals 5. And if I go to the other side, x equals negative 1, negative 2, x equals negative 3, x equals negative 4, x equals negative 5. So my x values change because I'm flipping from one side to the other. So this means my new A prime is going to be 5, positive 6, positive 5, positive 6. Are you guys with me? Am I going too fast? Am I going too slow? Are you alive?
It's fine.
Okay, anyone else? Anyone confused and wanted me to go back and talk about the one before? If you don't speak up, I'll never know. All right. B prime. My x changes, negative 1, comma, negative 2. C prime, my negative x is 3. My y did not change at all. Pink. Sorry, pink is up here. Blue. Ugh. Blue. Okay, I'm doing it again. You know what I need? A clock. You'd think with 2 laptops in front of me that I'd have a clock, but I don't. Okay, I kind of need to go a little faster. Okay, so I'm going to do that. A, negative 5, 6. This is like one of those days where I'm going to teach all the way to the bell. 1, negative 2. B. C, negative 3, negative 4. Okay. over the y-axis means that my triangle is going to be on the, like over here, right? Now I'm going to do my blue 5,6. A prime, -1, -2. B prime, +3, -4. C prime, okay. See how this middle line, I'm even gonna draw like, it's called the line of reflection, straight down the middle. How are you gonna see it? Oh, I could try a highlighter, maybe. Straight down the middle is my line of reflection. And look, 2 spaces away from C, wait, 1, 2, 3 spaces away from C in one direction, 3 spaces away from C in the other direction. So I know it's dead center because it's right down the middle. All right, moving on, we've got to. What reflection maps triangle KLM to its image? This is my pre-image. This is my image. So look, you guys, like this L is 1 space away from my line of reflection. This K is equidistant from my line of reflection. M, equidistant from my line of reflection. If I show it to you like this, does this help your eyes? It's like the triangle I had before. Here to here. What line is that? I took it on page 1 of notes, page 2 of notes. What is this line called? This dotted line that moves upward. Someone tell me, please. Reflected, what line is that? Right here. Uphill, the slope is 1, the y-intercept is 0. Ryan.
Y equals -x.
Negative x means that it's a downhill line. I've got an uphill line.
Oh, y equals x then.
Yep, and I say triangle KLM. Okay. Example 6. What is the reflection rule that maps each triangle to its image? Well, my 3, 8 became a -8 and a -3. My 5, 12 became -12 and -5. So my ordered pair is switching and they're both becoming negative. My E became from 4, 6 became -6, -4. So go back to page 2 of notes and look, I want the ordered pairs to switch and for them both to become negative. Volunteer.
Are y is equal to -x?
Avery, y equals -x. True, true. And I would then say, oh, I could say triangle CDE. I guess that's the, yeah. Ooh, I have time. I'm gonna use every spare moment I have. Your homework is attached, by the way. Just keep clear on that, and you need to do it by hand. If you have this paper, get it, find it. Ask a neighbor, ask your mother.
If we don't have it, do we absolutely need it? I don't remember if you said that.
See, sometimes you can use lined paper and it's see-through enough, like it'll work, right? It's not the worst thing in the world. It's better than nothing. But I'm just saying it will help you if you're able to get it. It will be a benefit to you this entire chapter. And I'm going to use it when I do notes with you. But if you can't swing it, you can't swing it. That's just the way it goes. I'm going to get a sharp pencil for this. Sorry. I have to draw the graph myself. Because these ordered pairs don't have any pattern that I can see by looking at the numbers. When you make your own graph, you really need to be consistent with your spacing of your marks. Equidistant, please. Don't be all over the place. See, that one wasn't even that good. Yeah, this one's really bad. Okay. Let's do pink and blue again. Pink, blue. Isn't this such a nice break from like proofs and solving for X? F, G, H. F. Okay, 7, 6. Like there. G, 0, -4. H, -5, 0. This is a giant triangle. Okay. All right. Blue. -5, 6. -5, +6. Wah. F prime. G, 2, -4. G prime. H, 7, 0. Okay, check this out. For sure this triangle flipped direction, but it's not the y-axis. Okay. In order for this triangle to become over here, the line of reflection runs straight down the middle. So here's what I'm going to do. Right now, I'm going to look at my G's because they're so close together. They are 1, 2 spaces away. 2 spaces away. So my line of reflection is obviously going to go up and down. Do you guys see that? That my line of reflection goes up and down? Because the top skinny right here is the top skinny over here. So obviously it flips like this. Okay. My line of reflection is straight down in between 2. That's from the X 0, 0, I go over 1. This green line that I just drew is X equals 1. That's the equation of my vertical line. Reflection is X equals 1. That's hard. That's a challenge problem for sure.
Wait, can you explain how you got Rx equals 1 again? I didn't quite get it.
If I know I can even do like this. If I know that my skinny area is up here, okay, here's my x-axis. Ugh, so bad. Now I can be like, oh, maybe I reflected over the x-axis. No, that's not it. Maybe I reflect it like the only other option I can think of is to turn my paper the other way. But then I'm like, well, that's not the y-axis exactly, because the y-axis doesn't cut it down the middle. I need my pink and my blue to be cut down the middle. The middle is in between my G points down here, because they're 2 away. So I can say, well, in between them, that's the middle. They're equidistant. See now, H blue H prime is equidistant from pink H prime, or H regular. So it had to be, I can't like go down because my skinny F corner vertex has to stay up high. So I can't like rotate it down. So it's reflecting it across, and I have to find the middle line myself. I happen to find the middle line because I used my G's as a guiding point. And this is also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 away. 6 away, 6 away. That helps me too. They're 12 total apart. Halfway is 6. That's how I got it. Okay. I have to let you go. Your homework tonight is to do the worksheet. You're not going to watch a video. Tomorrow in class, we're going to go, I'll give you the answer key to the homework page, and then we're going to start on 3.2a. Okay?
Can we put the homework in the digital?
Yeah, you post your homework on Google Slides, Chapter 3 digital notebook.
Okay,
Which
thank you.
one's homework? What worksheet?
It's attached to this paper that the PDF that I put on Google Classroom.
So would it be 1 through 18?
Yeah,
By what time do we post it?
you should post it before you see me tomorrow. So.
Okay, thank you. Have a nice day.